Good afternoon, Year 7. Today we are going to be looking at motion, and there is no better place to start than by talking about Sir Isaac Newton and his 3 laws of motion. Now, you may have come across these before, a couple of years ago, when you looked at motion in Year 5, but I'd like you to see if you can think about and write down in your notes if you can remember his 3 laws of motion. I will give you some time now to write those down if you can remember them. And for those of you who might be struggling a little bit, okay, here is 3 different graphics that might help you to remember them. Well done if you've managed to get 1, 2, or 3 of them. But over the next few slides, we're going to be looking at each of Sir Isaac Newton's laws of motion in a little bit more detail, so you'll have plenty of time to write down the exact laws of motion. So, starting with Newton's first law. According to Newton's first law of motion, an object remains in the same state of motion unless a resultant force acts on it. If the resultant force on an object is 0, this means a stationary object stays stationary, or an already moving object continues to move at the same velocity, which is the same speed and in the same direction. Try and think back to yesterday to remember what a resultant force is. Remember, it's the overall force acting on an object. You will also notice that in the bottom left-hand corner of this slide there is a pencil, so you need to make sure that this slide is written down in your notes for today. Okay. Once you have written down these notes, you can go to the next slide, which is a YouTube video, which is an explanation of Newton's first law. So take a look at the video, and then once you've done with the video, you can move on. Which then brings us to Newton's second law, which can be described by the following equation. The resultant force is equal to the mass times by the acceleration. So force is equal to mass times acceleration, or F equals ma. Once again, there is a pencil in the bottom left-hand corner, so please note down the information from this slide. And again, just like the last law, which was Newton's first law, there is a video for you to watch to help explain what Newton's second law exactly means. So take a look at the video and then move on to the next slide. This slide now is looking at Newton's third law. And Newton's third law of motion states that whenever 2 objects interact, they exert equal and opposite forces on each other. Now, this is often worded as every action has an equal and opposite reaction. However, it is important to remember that the 2 forces act on 2 different objects and are of the same type. For example, they are both contact forces. Remember, you need to note these down in your notes as well. The pencil is in the bottom left-hand corner. Once you've written down the notes in the slide, you can move on to the next slide, where again you'll see a video which will explain Newton's third law and give you some examples. Now remember, if you'd like to add some of these examples or add extra information into your notes, then please feel free to do so. Now that we've looked at Newton and his 3 laws of motion, for the rest of the lesson we are going to be doing the following. We're going to be defining acceleration. We're going to investigate some forces which might oppose motion. Okay, and we're also going to apply some knowledge of Newton's laws to some simple graph questions. Now, part 3 will only be done if we have extra time. If not, we will carry on and finish it in a future lesson. So now looking at acceleration. It can be determined by the definition of the rate of change of velocity per unit time, which if you break down the word velocity means speed, so it's the change of speed over a period of time. Now obviously a change of speed can be It can speed up, which is acceleration, or it can slow down, which is called deceleration. So overall, acceleration is a change in velocity over a period of time. Pencil in the left-hand corner at the bottom, so please note down the information on this slide in your notes. Now, this is a little bit of a reminder from yesterday's lesson where we were looking at force diagrams and where we draw the arrows. Remember, we must draw them with straight lines, we must draw them using a pencil, and we also need to correctly label them. Ideally, we'd also like them to come from the centre of the object, but obviously, if that means drawing them on the outside of the object to make sure they're visible and clear, then that's also fine in this instance. So, I would like you to redraw the car and add all the force arrows. You can simply copy and paste the picture of a car from this PowerPoint into your notes, or you can find your own picture of a car, but it must be from a side-on view. You need to add the arrows for weight, friction, reaction force, which is the force of the ground pushing back up from the weight of the car, and you also need to add driving force and air resistance. Once you have added the arrows to your vehicle, the next slide will help explain where those arrows should have gone. Remember, if you have any questions or queries about the direction of the arrows, then do ask the question in your channel, the correct channel for your class. Now, I mentioned earlier that we'd be looking at forces that oppose motion, or in other words, that go against motion, so the opposite way to the direction of travel. So, our definition for friction is the resistance to motion of one object moving relative to another. Now, friction always works in the direction opposite to the direction in which the object is moving or trying to move. Friction always slows a moving object down. Friction can never speed an object up. Okay, it always slows a moving object down. Now, pencil in the bottom left-hand corner, so please can you make sure you note the definition and the extra words down explaining what friction is and how it occurs. For the next part of the lesson, now that you've just understood what friction is, you are going to design your own experiment to investigate how friction affects the speed of an object. Now, you need to set out your experimental design in the same way that we've always set out our experiments. So, starting with a title, then a prediction, mentioning the apparatus that we're going to be using, the method of how your experiment's going to work and what you're going to do, the results, so what occurred, what happened, and then a conclusion which gives me or you also a summary of your findings. Now, the apparatus that you're going to be using is a wooden block with elastic bands attached to a Newton meter. Now, a Newton meter, as you pull it, okay, measures a force. Now, you're going to try and pull it at exactly the same force each time, and you're going to pull your object, which is a wooden block or a shoe, across a variety of different materials. For instance, I've labelled two here. You could use carpet and cardboard. Okay, you could also use a kitchen surface, you could use wood, marble, any sort of material that has a difference in surface. Now, if we think back to some of the materials we've looked at over the years, you're probably going to predict that smoother surfaces will let objects slide more easily. But this is something that you're going to find out. Now, obviously, you can't actually perform this experiment because you probably don't have a Newton meter at home. But I would like you just to estimate what you think is going to happen and carry out this experiment as if you have done it. If you have access to your ISEB textbook, the green small physics one, pages 64 and 65 may help you with planning your experiment. Now, if you don't have this textbook handy, then do not worry. This is just extra help if you can have access to it. Now that you've completed your experiment design and experiment, there are some questions for you to think about. So, in your notes as well, I'd like you to write down how you think you made this a fair test. Can you think of 3 ways of how friction can have advantages or disadvantages? Then have a think about what can decrease friction. Is there any way that we can reduce friction from occurring? Again, IRCEB textbook pages 64 and 65 might be able to help you with your experiment write-up. Now, I hope you managed to come up with 3 advantages and disadvantages of friction. If you were struggling, then there are some more examples here. Again, you can add these to your notes if you would like. If your 3 that you've already written aren't sufficient, then just add in any extra information that you need. So advantages, for instance, prevent sliding and slipping when walking or running, nails in wood, corks in bottles, brakes on bicycles, motorbikes, cars, trains and planes, tying your shoelaces in a knot, parachuting and hang gliding. Friction between the air and the canopy saves your life and lets you lower to the ground nice and safely. Now, disadvantages, you have things like increased wear and tear. So the soles of your shoes or brake pads, car tyres, these all need to be replaced every so often because friction has worn them down. Another disadvantage of friction is heat. Machinery parts can become very hot, leading to expansion problems. Also sound. Friction tends to create sound. It also can slow the movement of things like cyclists, skiers, cars, trains, and planes. So, what can we do to overcome friction? Well, a fantastic example is a lubricant. Now, a lubricant is a substance which lowers friction between 2 objects. For example, oil. So again, could you please write down this definition of a lubricant? And this is one of the ways that we can overcome friction. That is all for today's lesson on motion. Thank you very much for listening. Make sure that you save your notes. You do not need to send them to your teacher yet. We will look at your notes later on when you've completed a couple more lessons on forces. So just save your work in your forces folder and enjoy the rest of your afternoon. Look forward to seeing you tomorrow. Goodbye.